Okay, we're doing a similar thing, but we're adding a step of complexity because now our value in front of the parentheses is not going to be just 1 or -1. That might happen on one of them, I can't remember. But I wanted to introduce this idea of having a vertical stretch or a vertical shrink. And I'm sure that we can imagine stretching something or shrinking something. Another word for vertical shrink is a vertical compression, right? So you're making it smaller. But when we're doing this, it's only actually affecting it vertically because it's outside the parentheses. There are such things as horizontal shrinks and stretches that are part of the super secret opposite society, but it gets weird. So we're not going to worry about that right now. We'll talk about it extensively in Algebra 2, but right now we're just going to have vertical stretches or shrinks. And what's going to happen is that it should do what makes sense, by which I mean that this 2 is going to be a stretch by 2. What does that mean? It means that the points are going to go twice as far as normal. Okay? So first off, our vertex is opposite of +1, so -1. And our y value is -3. And it's a +2, so it opens up. But whereas normally I go out 1 and up 1, I need to go up twice as far. So I'm going to go out 1 and up 2 on both sides. So see how that's already stretched. And so then normally I next go out 2 and up 4, but I need to go twice as far. So what's twice as much as 4? It would be 8. So I'm going to go out 2 and then count up 8, which should be here. Trying to line these up. And here's my parabola. If we were to draw the parent graph x squared, or even just this graph without the 2, it would probably be easier to notice that, yeah, this graph is actually narrower because it's going up faster than it normally does. So describe the transformations. We have a vertical stretch by 2, a shift left 1 and down 3, something to that effect. Okay, on this next one, oh no, it's a fraction. What do we do? So if timesing by 2 stretches it by 2, then timesing by 1/2 stretches it by 1/2. Oh wait, that would actually be a shrink, right? So this graph is actually going to be wider because it's going up more slowly than the previous one. So I'm still going to start with the vertex at 2, -1. Remember, it's the opposite of what's inside. It's a part of the super secret opposite society, which, interestingly enough, is not quite as secret as it once was because math teachers keep talking about it. So that's where my vertex is. I'm vertically stretching by 1/2. So instead of going out 1 and up 1, I need to go out 1, but only up 1/2. And this is where it may be a little bit frustrating because that's a fraction, and I know how we all feel about fractions probably. Next, we go out 2 and up 4, but I want to go up 1/2 as much. So out 2, up 2. Well, that was a nice whole number. So the other direction right here. And I mean, if we did the next set of points, so out 3, up 9, divided by 2 would be 4.5. Like, we're going to start to really see that it's pretty wide compared to our first one, at least, for sure. I'm not saying you have to graph these points. I just wanted to for some reason. So that graph is wider. So we vertically compressed or shrunk or shrink, vertical shrink by 1/2, and then shift right 2 and down 1. Okay, this last one has a -2 in front. So you, I guess, could say that you're stretching it by a -2, but you can't, like, that doesn't actually really make sense to say that we're stretching by -2. What we're doing is we're stretching by 2, but the negative is telling us that we have a reflection. So I'm going to start with the vertex, which is the opposite and the non-opposite. So -1, 2. I'm going to stretch by 2, but I'm going to go down instead of up. So instead of out 1 and down 1, I need to go out 1 and down 2. Just like what we did on A, except for we're going down instead of up. It's actually also in a slightly different place for the vertex, or a different place for the vertex. Out 2 and down 4, but I really need to go down 8. So just like that. So this was a vertical stretch of 2, shift left 1, and up 2, and also a reflection. I know I didn't give you a ton of room. Hopefully you can make it work. Reflection over the x-axis. And there we go. And because of us ignoring the idea of horizontal stretches or shrinks, this is as complicated as it gets for vertex form. So check your answers, make sure everything's going okay, and yeah, have a good one.